Hello everyone, I am Pranati from KL University. So today we have come up with a topic called Hive and Hadoop ecosystem. So before seeing what is Hive, let's see what is Hadoop in brief. So what is Hadoop? As we all know, Hadoop is an open source framework which is used for storing and processing big data in a distributed environment. It basically contains two modules, MapReduce and HDFS. HDFS which refers to Hadoop distributed file system. So MapReduce, it is used for parallel programming. Um, which helps in processing large amount of structured, unstructured and semi-structured data on large clusters. HDFS, Hadoop Distributed File System, as a part of Hadoop framework used to store and process the data sets. It provides a fault tolerance file system to run on commodity hardware. So Hadoop ecosystem also has some kind of tools which helps in running the Hadoop modules. So some of the tools are like Scoop, Pig, Hive, etc. And so in which we'll be discussing more about Hive. So let me just give you an introduction of what is Scoop and Pig. So in Scoop, it is used for importing and exporting data between HDFS and RDBMS, that is importing and exporting of data between a Hadoop distributed file system and relational database management system. Pig, it is a procedural language platform used to develop a script for MapReduce operations. For performing MapReduce operations, it develops or generates a kind of script which is used. And Hive, it is a platform used to develop SQL type scripts to do MapReduce operations. So we'll see in detail what is Hive. So Hive is a data warehouse infrastructure tool to process structured data in Hadoop. As we have seen, MapReduce deals with structured, semi-structured and unstructured data, and Hive is a part of it, helping it solve its operations. So Hive deals with only structured data. It resides on top of Hadoop to summarize big data and makes querying and analyzing easy. Hive provides the functionality of reading, writing, and managing large data sets residing in the storages. So it runs SQL-like queries called HQL, Hive Query Language, which gets internally converted to MapReduce jobs. Using Hive, we can skip the requirement of traditional approach which says writing complex MapReduce programs. So Hive also supports data definition language, data manipulation language, and user-defined functions. Initially, Hive was developed by Facebook. Later, the Apache Software Foundation took it up and developed it further as an open source under the name Apache Hive. So as we call it now, it is used by different companies. For example, Amazon uses it in Amazon Elastic MapReduce. So the features of Hive are it stores schema in a database and processes the data into HDFS. It is designed for OLAP. It provides a SQL type language for querying called Hive SQL or HQL. It is familiar, fast, scalable, and extensible. It uses indexing to accelerate queries. It allows different storage types such as plain text, RC file, and HBase. It is capable of analyzing large data sets stored in HDFS. So, have a look at the architecture of Hive. Next, the commands used in Hive. So this I will be showing in the demonstration part with a detailed explanation of it. So what are these and what Hive in Hive, what can the commands be executed? See, just have a look at the commands. It shows like a show database, create database, using the database, next creating the tables in it, dropping it, and also alteration of the tables, making a copy of the tables. All these commands can be done in Hive. So now comes the topic partitioning in Hive. So basically partitioning, the word says it is dividing. So here in Hive it means dividing the table into some parts based on the values of a particular column, like example date, course, city or country. The advantages of partitioning is that since the data is stored in slices, the query response time becomes faster. As we know that Hadoop is used to handle the huge amount of data, it always requires the best solution to opt it. So one such solution is Hive. Let's assume we have a data of 10 million students studying in an institution. This is a real-time example. Now we have to fetch the students for a particular course, which is very difficult by using the traditional approach. So traditional approach, it leads to the performance degradation. In such case, we can adopt the better approach, that is a Hive, partitioning in Hive, and divide the data among the different data sets based on particular columns. Next, types of partitioning. So we have two types of partitioning in Hive. One is static partitioning and the other one is dynamic partitioning. So let's see what is static partitioning. In static or manual partitioning, it is required to pass the value of partitioned columns manually while loading the data into the table. Hence, the data file doesn't contain the partitioned columns. So inserting input data files individually into a partition table is called static partition. If you want to use the static partition in the Hive, you should set the property set hive.mapred.mode equal to strict. This property is set by default in hivesite.xml. Now static partition is in strict mode. So now let's see what is dynamic partitioning. In dynamic partitioning, the values of partitioned columns exist within the table. So it is not required to pass the value of partitioned columns manually. So to enable the dynamic partitioning mode, here are the two commands given below. So in dynamic partitioning, single insert to partition table is known as a dynamic partition. Dynamic partition takes more time in loading data when compared to static partitioning. If you want to use the dynamic partition in the Hive, then the mode is in non-strict mode. As in static, it is in strict mode. So now let's go to the demonstration part of static and dynamic partitioning in Hive. For that, you have to open your virtual machine. I have my virtual machine in CentOS. Now open the terminal. So first check in which directory you are. If you are in desktop, then just type cd. Now start the DFS. Next start the yarn. Now let's check with the command JPS whether the nodes, yeah, perfectly they are all running. So now go to Hive. This will take to the Hive command prompt. So there we can do the static and dynamic partitioning. It will take quite a time, yeah. So we have entered the Hive prompt. Now first we'll start with static partitioning. For that, we have to create a table. Creating a table in a database. So let's see what are the databases available. So I have a database called db1, so let's use it and also show the tables in it. Okay, I don't have any table called student, so let's just create it. Create table student with the attributes SID of integer type and SNAME of string type and a percentage of float, partitioned by section string. Next row format delimited. Fields terminated by a comma. Yeah, so let's see student table. Yeah, you can also see the partition information. And now open another terminal. So here I have already created some data sets called data1, data2. So let's see what's the data present in it. You can use cat data1. So I just have some data in it, some random data, and also in data2 also have some random data. So let's just go back to the terminal 1. Now you have to load the data. that we have seen in the data sets to the student table. So load data local in path, and now you have to give the path which the data is present. So as we have seen the data in the home Hadoop slash data underscore 1, so it is present there, that you have to load it into table student. Partition by, as we have given the section, so let's just give section A. See, the data is loaded. Now let's just see whether it worked or not. So this use the select statement. Yeah, so you can see the data which is present in data 1 set data set, that is loaded into the student table successfully. Now just load the data 2 also, say with using the similar commands into the student table. So just here you have to change the dataset name and also the partition. Now let's just make it a section B. See, the data which is present in data 2 dataset also is now loaded into the student table. This is called static partitioning. So for dynamic partitioning, create another table. I'm creating an external table by using the command external. So let's just name the table name as food prices, as I have the data set of food, so which contains the attributes of FID and product name, which is of type string, and the year, it is of string. Row format delimited. So here we are not using the partition condition as we have used in static partitioning while giving it with the tables. So that is the difference between static and dynamic. And fields terminated by a comma. Stored as text file, as we have stored the data as a text file at the location, I'll specify it, home slash Hadoop slash food. Let me show you the text file also. So I'll just show you the text file. So here I have a food which contains some food items and the years also. So this is the text file which I'm going to use as the data set for current dynamic partition. So just load that data into the food prices table. Into the food prices table. Yeah, so the data is loaded successfully, that we can check it by the select command. Yeah. So now let's just create a partition table. That is also I'm creating an external partition table. Food partition, I'm naming it as, with the attributes if ID of int type and product of string, which will be partitioned by the year which we want, which is of string type. So now you have to set the Hive environment to dynamic partition, for which the following command is used. So this mode should be set to non-strict, as I have explained it earlier also. Now let's just insert into the table that we have created right now, food partition. So now the data is getting inserted, and after that you can see the partitions, how many partitions are available in the food data set by the specification of the year. So it takes a little time, bear with it. Yeah, so we are done. So now show partitions from the food part table. So here are the partitions as we can see in the data set. Let me just show you again the data set. So here we have different types of partitions like 2020, 2021 and 2022, which represents, here the years are partitioned by 2020, 2021 and 2022. So this is dynamic partitioning. So let's see the advantages and disadvantages of partitioning in Hive also. So the advantages goes here are partitioning in Hive distribution execution loads horizontally. In partition, faster executions of queries with the low volume of data takes place. For example, search volume of Vatican City returns very fast instead of searching entire world population. So the disadvantages are there is a possibility of too many small partition creations, too many directories, which makes it difficult to search. Partition is effective for low volume data, but there are some queries like group by on high volume data takes a long time to execute. For example, grouping population of China will take a long time as compared to a grouping of the population in Vatican City. There is no need for searching entire table column for a single record. So in summary, today we have learned is what is Hive and also the partitioning in Hive, and what are the advantages and disadvantages of it. Also we have seen the demonstration of static and dynamic partitioning in Hive. Thank you for watching the video until the end.